Okay. So I gave you an example like that. That is IVP problems. And I want you guys to do two things. Verify x C1 cosine 4t C2 sine 4t is the solution of ODE. Okay. Verify is the solution of the ODE, and then find the C1 and the C2. Okay. Now, like I said before, for such IVP problems, if I give you the solution, you need to verify that's the solution for the ODE. Okay. After you verify the ODE, and you can solve it, these initial conditions, using this initial condition to solve the C1 and C2. Okay. And here we have two initial conditions and the two unknowns. You're supposed to be able to solve it. These two unknowns. Okay, try it by yourself. So, I want to mention again, here is a second order differential equations. For the second order differential equation, we require two initial conditions. Okay, if I give you a first order differential equation, you need one initial conditions. Okay. Okay, now let me do it on board. So like I mentioned before, the first things you guys needed to verify this ODE equation. That is second order ODE. Okay, let's take a look. So let's take a look the left hand side, right? And of course, this one is a little bit tougher because it requires the trigonometry stuff, right? So if you still remember, you should know how to do the derivative for the trigonometry functions, trig function, okay? So we have cosine okay? And I think here we have two derivatives, right? So let's do the derivative for the first one. So derivative for this guy will be a cosine sine, and it should be a negative. Aha, good job. Okay, and of course here we have 4t. That means we're gonna use the property of composite function. So here's a derivative of 4t, right? Let's see two. And this guy, sine gonna be a cosine. And of course, it's a composite function. So 4t gonna be a negative 4 c1 sine 4t, 4 c2 cosine 4t. Okay, now we're gonna do that again because we finished the first derivative. Now we need to finish the second derivative. So the same change. Do the derivative of the first term. Keep the constant the same. This guy gonna be a sine cosine. And that is a composite function. So we have 4t. And the second one will be negative sine 4t and composite function, right? Okay, so we have what? We have c1 cosine 4t times 4 and 4c2 sine 4t times 4, right? And we have 16 cosine 4t. And we're gonna have negative 4t. Here's a negative c2 sine 4t. Okay, we get this one, right? Now we can cancel out. That's equals 0. That equals right hand side, right? Right hand side. We just prove it. We just prove that that's the solution of the ODE. Now, we need to solve this C1 and C2. How to solve it? We're gonna use the initial condition here. Initial conditions. There's two initial conditions to solve these two unknowns, C1 and C2. Okay, so let's take a look. The first condition. The first condition is this guy, x pi over 2, right? So here is t equals pi over 2. Should be a C1 cosine sine 2, plug in the t, 4 times pi over 2 equals -2 here. Okay, we get the first equation, and the first equation we can simplify it. Okay, now I have a question. So what is the cosine 2 pi? Cosine 2 pi equals what? Cosine 2 pi equals what? It's radial, right? It's a 1/3. If you transform it to degree, it's gonna be 360. So it should be what? Any idea? It's 1. If you don't know, use your calculator. Okay, so it should be a 1. How about the sine 2 pi? How about the sine 2 pi? Okay, I'm gonna draw the picture. For the sine should be for the sine. Okay, should be from here to here. Is from 0 to 1. 0, -1, right? So here's a 2 pi, then it goes to 1 circle, goes back to here, right? So it should be a 0. And for cosine should be what? Should be 1, 0, -1, 0, right? So if you start with 2 pi, goes to 1 circle, is here, should be a 1. If it is a pi over 2, it should be 0, right? So that's the basic stuff you should learn from your trigonometry, right? That's a check function. Did you guys still remember or not? You guys should take this class before, right? Just being a long time, you probably forget it. But you guys still can use your calculator if you are not so sure, okay? So we're gonna get C1 equals -2, very straightforward, okay? C1 equals -2. Now we're gonna use the second condition. However, before you use second condition, you should realize that is a derivative. Okay, that is a derivative. So that means what? We need to do the derivative firstly, then we plug in the pi over 2. Okay, it shouldn't be the way you plug in pi over 2, then do the derivative. That's wrong. Always do the derivative firstly, then you plug in pi over 2. Okay, so that's the point. So how to do the derivative for this guy? Just follow the way, right? Derivative of t should be I just copy it. Okay, and the derivative of first one gonna be a sine negative sine 4t and a 4t derivative. Be careful, here is a composite function, right? We treat this one as another function. So cosine becomes negative sine. And this part is gonna be the composite function, another function, derivative of another function. and this guy cosine and 40. Okay, composite function. Here is a 4, so negative 4 C1 sine 40. Okay, we did a very good job. We did a very good job. Right? We have such things. We have such things. Now we plug in pi over 2. Because here is pi over 2, right? So we plug in, we're gonna get what? Let's take a look. And that equals 1, right? Based on the condition. And let's continue. We can simplify it. Sine 2 pi gonna be 0, right? So here is 2 pi gonna be 1. Okay, here's a 1, here's a 0. We don't need to care about 0. So C2 equals 1/4. Okay, so we got a C1, C2. Then we plug in x equals what? X give you the -2 1/4. Okay, so that's it. Understood? Okay. So the difficulty of this problem is always about the derivative. How to do the derivative for the check functions. Okay, it's not difficult to verify this problem. It's difficult to do the derivative because it utilizes a lot of your previous knowledge. Okay, previous knowledge. How to do the derivative for the composite function. Okay, how to do the derivative for the check functions, right? Check functions. So a lot of things you guys needed to learn it to learn from your calculus, not from this class actually. Okay. Okay, so now let's continue. We already finished this section. We're gonna go to another section. I'm gonna give you guys another example. Okay. I have another example. Found actually this one is from the homework. So, I think it's pretty important. Maybe gonna help you guys a little bit more. For which homework example? Okay, right down here. For which the function y equals x to the power m is a solution of the given differential equations. That is Okay. The first things you guys need to know is that guy is the solution of this one, right? So when you plug in this guy into this ODE, the left-hand side should always equal to right-hand side equals 0, right? So try it by yourself. We're gonna do very similar things. We do the left-hand side and the right-hand side. Let the left side equals right-hand side. Then you can find the m. Did you get it? Jivan, did you get it? Almost. Okay, let me do it on board. So the left-hand side, we have plug in, right? plug in the x. Okay, so then we have what? Do the derivative of this guy. We're gonna use a power rule, right? And do the twice, you're gonna get like that. And if you do twice for this one, you're gonna get. Okay, I think this one is pretty straightforward. Right? So I skipped 1 steps. And now you're gonna get what? You're gonna get okay, because x to the power 2 plus times this guy gonna give you x to the power n. And if I x times x to the power n minus 1 is x to the power m. And we're gonna have what? M squared minus m plus 2m minus 2. Factor the x to the power m. And we can simplify. Right. See, the left-hand side should equals right-hand side, right? Right-hand side is 0, right? So that means this guy equals 0. What does that mean? That means this guy equals 0, right? This guy should equal 0. Because this guy equals 0, that means this guy should equal 0. Okay? This guy equals 0. Okay, in order to let this guy equal 0, we can solve it very quickly using the factoring method. If this guy equals 0, we're gonna oh here's plus. I make a mistake, sorry. So we have 2m plus 2 equals 0. We get the two solutions. So one is m1 equals -2, m2 equals 1. Okay, so we get two solutions for the m. That's a typical problems on your homework. Okay. Okay, now let's move forward. We're gonna go to another chapter. You copy everything? Okay, good. Now let's go to another section. And an ordinary, ordinary differential equation in which the independent variable doesn't appear expressly is said to be autonomous. autonomous. Okay. So what is autonomous? Autonomous what? It's independent variable, doesn't appear expressly. Doesn't appear expressly. Let's take a look. An autonomous first order ODE equals 0, then okay, there is no independent variable. Okay, there is no independent variable because here only about y. There's nothing to do with the x. Correct? This derivative equals something with the y, nothing to do with the x. So there's no independent variable here. Okay. So let's take a look. This guy. Is that ODE autonomous or not? Autonomous or not? Yes, because here has nothing to do with independent variable. How about this one? Is autonomous or not? Not. What's the independent variable here? Little t or capital T? Little t, right? That's the little t. So right hand side has nothing to do with independent variable t, right? So that is autonomous. If I change the big capital T to the y, little t to the x, you can tell very easily, right? But now I change a little bit, use other symbols. You need to be careful, okay? How about this one? Autonomous or not? No? Yes? No? No. Okay, good. Non-autonomous. Because here is very clearly we have independent variable, little t here, right? Okay, very good. So that's the definition of the autonomous or non-autonomous. Now let's take a look at another critical terminology. We call it the critical point or equilibrium point or stationary point. Let's take a look. We're gonna use this ODE. Okay. A real number. Real number. This means a number. Okay. A real number C is a critical point of the autonomous differential equation 1. And the 1 is what? 1 is this guy, okay? This guy. If it is a 0 of f, that means what? We found a c, a constant c, or a real number c, that when we plug in the c here, we found this function equals 0, or this right-hand side equals 0, okay? So we call this guy as critical point. C as a critical point. And of course, we called is a constant solution of the autonomous differential equations. A constant solution Yx equals C of 1 is called an equilibrium solution, okay? And this guy we call the constant solution, or we call the equilibrium solution, okay? So that's the definition. So first things you guys need to know how to find the critical solution. Just let what? Just let the right-hand side, this guy equals 0, right? Let this guy equals 0. We solve the C. Solve the C. We found the C, right? Solve the C, or solve the Y. We got the C. Okay. And then let Yx equal C. That is the equilibrium solution. I'm going to show you guys a specific example. So let's take a look at this example. Example here, dp over dt plus pa minus bp. Okay, let's take a look. Is that autonomous or not? Yes, it is, because right-hand side has nothing to do with the t, right? Okay, so the second step, we need to find the critical point. How to find the critical point? Based on definition, we just let the right-hand side equal 0, right? Solve the C, or solve the P, right? So we just let right-hand side equals 0. That's it. And to solve this guy, we have two solutions. One is 0. Another one is we can solve it, and we can quickly get that the second solution going to be A over B. Okay, we have two solutions. And these two solutions, if we plug in these two solutions, we're going to let the right-hand side equal 0. So that means we have two critical points. One is 0, another one is A over B. Okay, just let the right-hand side equals 0 and solve the equation and find the solution. If we find one solution, we get one critical point. If we find two solutions, we're going to get two critical points. Here we have two critical points. And what is equilibrium solutions? Since we find solutions. Here it's just two solutions, right? Based on definition, that is yx equals c. Here is a p, right? Y is a p. So pt equals 0 or pt equals a over d, right? That's it. So that's the equilibrium solution. So the purpose for this example, just try to help you guys to understand what is critical point, what is equilibrium solution, or how to find the critical point or equilibrium solution. Okay, I think it's not too hard as long as you understand the definition. How to find the critical point? Just let the right hand side equals 0. Right? Question.
Why did they? Where did they come from?
It's here. You solve this guy, you get P2 equals A or B, right? So you got a two critical point. Just let P2 equals 0, P2 equals A over B, right? Just based on the definition, right? Let the dependent variable equals C. Here dependent variable is P, right? Okay, I'm gonna give you guys an example. Let you guys try it. Find the critical points and equilibrium solutions. Okay. First of all, you guys should to notice that is autonomous differential equation. Okay. If it's not autonomous differential equation, that's no critical points. Okay. Okay, now let me do it. Did you get it? Okay, now let me do it. So for the critical point, what you can do is let the right-hand side equals 0 to solve this guy. And you're gonna get this guy, a equals 600. Right? So the critical point is 600. And the equilibrium solution shall be AT equals 600. 600. Okay. Is that clear, guys? Okay, very good. So now we're gonna move to another section, 2.2. And I think the 2.2 gonna be the foundation for you guys to solve the ODE problem. Okay, the foundation, and that section, this section gonna introduce a method we called separable equations. Okay, separable equation or separable variables. Separable equations, or we can say separable method. Let's take a look at the definition. First order differential equation of the form we have dy over dx gx hy okay, and we is that to be separable or to have separable variables. Separable variables. Okay. So let's take a look the definition. Separable equation dy over dx can be written down as a function of x and times a function of the hy times or multiplication. Okay, that's nothing to do with plus or minus. Okay, if this two function is separable, that means what? A function of x times a function of y. Okay, or this function can be a constant. Okay, for constant times hy, or this hy can be a constant, just be c times gx. Okay, now I give you guys a function like that. Is that separable or not? Take a look. Separable, right? Because here is a function of x, here's a function of y. So that, guys, is separable. How about this guy? Is that a separable function or not? Yes or no? Yes, because gx can be a constant, right? A constant times y squared. Oh, here we don't have x, but we can be like I mentioned before, can be a constant times hy. So separable. How about this one? Oh, x plus y squared times y is separable or not? No, because here's addition, x plus y squared, right? It's no. Very good. So as long as you guys understand what is separable, now I'm gonna give you guys another tough one, okay? This example is pretty easy. Now, how about this guy? This example 1, 2. How about this guy? Yes or no? Why? We need a multiplication, huh? Multiplication. The function of x times a function of y. Here is clearly that's subtraction, right? So it's separable or not? It's separable. Do you agree, Chiba?
Well, kind of suspicious.
You're right. He is very suspicious. So, but yes, you're right. You're right. Good job. It's separable because E can be written like that. Okay. So that means we can write that as okay. So here is a function of x. Here is a function of y. You can tell, right? A function of y. So it's separable. Separable. Okay. And the last one. How about this guy? So this one, yes, separable. How about this one? No? Do you agree or not? It's no. Oh, yes, yes. Why? Here's is a function of x. Here's a function of y. He has nothing to do. In this addition, do we have y? No, nothing. We have a multiplication. This is a function of x. This is a function of y. That's it. Yes. Right. Be careful. Okay. Okay, so since we know what is separable functions, so we're gonna introduce a specific method. We call it separable method. Separable method. Okay. Method of solution. So we know giving a separable function like that, we can write that as this way, because here divided by x, we can write that as like that. Okay, and we let right hand side only about the y, and the left hand side is only about the y, left hand side only about x. Okay, and then we can do the integral, right? Integral. For the left hand side, we do the integral with respect to the y. For the right hand side, we do the integral with respect to the x. You see it? And then we do the integral. That means we can write down as the antiderivative. Right? Derivative of this function, where hy, capital H, y, and the g, capital Gx are antiderivatives. Antiderivatives of hy and Gx. Okay, so basically we found a solution. If we know the antiderivative of 1 over hy, we can find the integral result is capital Hy. And then if we can find the antiderivative of little gx is capital Gx, we can write out Gx equals C. So basically this guy is the solution of ODE. Okay. So in reality, I'm gonna show you a very specific an example, a very specific example. Let you guys take a look. For example, I give you guys a very easy example like that. dy over dx equals to x. Okay, for example, equals to x or equals to y. Sorry. Okay, equals to y. How to solve this guy? We can use the separable method. Right, dy to dy dx. Since here we have y, we always put dependent variable on the what? On the left hand side, divided by y. Right? Is this it? dy over y equals to dx, and then do the derivative after you separate the variables. Right? So for the left hand side, we do the integral with 1 over y. What is the antiderivative of 1 over y? Do you still remember? Oh, you guys forget everything. You need to retake your cal too. 1 over y, antiderivative of this guy gonna be ln. Right? What about the antiderivative of this guy? 2x, right? 2x. And be careful, we always put a constant there. Okay, put a constant there. And some of you might like to write down is this way. Do the here's the ln, so we can write down is y e to the power 2x plus c, and the ec e to the power 2x, and let the ec be another constant, because e to the power c is still going to be a constant, right? So combine these two, or combine with the constant always, just put a constant there, okay? So this guy is the solution of ODE, okay? Now I'm gonna give you guys an example, let you guys try it. Try this one. Try this one. So the first step, you guys need to separate the variable. You always keep the y on the left hand side and the x terms on the right hand side, right? And then after you separate the variables, then you can do the integral for both sides. Okay. 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 I'm gonna show you guys on the board. Okay. So for this guy, follow our strategy and dy over y squared 3dx. And then we do the integral for both sides. Okay, the point is how to do this integral. So you guys forget something. This one is pretty straightforward, right? The point is how you do this integral. Gonna be a power law. It's the reverse process of the power law, right? I'm pretty sure some of you already forget it. Okay. That's the Cal2 stuff. Come on, guys. Okay, so we get this one. And you're gonna have negative y 3x plus c. And you can also write down is like that. And you're gonna get flip it. You're gonna get 3x plus c. And this is the solution of ODE. Okay, solution of ODE.